This is a Geek Leader podcast, and I'm your host, John Rauda. This show is all about helping us grow as leaders, become better technologists, and improve our lives both at work and at home. I hope you enjoy the show and learn a lot. Hello, world, and welcome to a Geek Leader podcast. I'm your host, John Rauda. Today's sponsor is A2 Hosting. I've been using A2 Hosting solid-state hosting solutions for our website at geekleader.com for many years now, and absolutely love their support, their service, and all the features that you get. You get access to cPanel. You get all of the things that you can imagine for a great WordPress experience, including their A2 optimized WordPress, which does extra security checks, extra lockdown. You can lock down your editor file so you can't edit anything inside there. You get alerts whenever there are file changes that are done. You can also do automatic updates, backups, and more with A2 Hosting. So highly recommend it. Go to geekleader.com/A2 to get more information and to sign up for their solid-state, turbocharged speed hosting today. Again, that's at geekleader.com/A2. All right, Geek Leaders. Today I'm honored to have Karan Talati on the show. He is the CEO and co-founder of First Residence. What was interesting with Karan when I got his bio sent over to me, I was reading through it, and I get a lot of these bios come over to me, and a lot of times they're not interesting. This one was super interesting because we talk a lot about Agile project management and software development and IT engineering, but one thing I've never talked about with anybody is Agile manufacturing. So I kind of want to talk about that and learn more about that, and hopefully that'll be as exciting to me as it is to everybody else that's listening. Anyway, Karan, welcome to the show.
It's great to be on, John. Thanks so much for having me. I'm excited to talk about these topics as well.
So if you don't mind, just give the audience a little background about how you got to where you are today in your career and what it is exactly that you do.
Absolutely. So I'll go back to when I was born. I'm kidding. Let's just go back a little over a decade. So, when I was going, from high school to college, I had some choices, as every one of us do, on what we want to do. I think sometimes that choice comes a little bit prematurely for people. I was always a little bit of a computer geek, hacking cell phones and kind of feature phones back in that day when it wasn't, kind of a network for app developers and the app stores that we have today, but rather, hacking into the Flex files that manage the configuration for the phone. So I actually, when I was a teenager, became a little bit internet famous. This is like Internet 1.0, that era of GeoCities and forums and whatnot. Of hacking some of the phones that were out there. You could think about the Motorola Razr, the original. They have a new one coming out, and doing things like that the carriers didn't want you to do and things like that. Nevertheless, fast forward here a little bit, was kind of a hacker type and good at math. Was deciding what to do in college. I actually at that time just didn't want to sit in front of a computer for the rest of my life. So I ended up not going into software engineering or computer science, and instead chose mechanical engineering. It turns out, a lot of people sit in front of computers these days, whether you're a mechanical or software person. But, I actually feel kind of fortunate for studying mechanical engineering because I think it's a skill set that is not as easy to pick up on the online these days. So love seeing the progress in self-made developers and, really honing the craft of software engineering through practice. And it's something, in the mechanical world, I was fortunate enough to just get through my college expertise. So, throughout that, studied mechanical engineering, didn't love it. Actually still was in love with software. So, went to hackathons, went to some of the first hackathons that were kind of happening in the early 2010s. Some of the listeners might know about like MHacks at Michigan University and how that kind of world developed into, major league hacking and all the cool things that we see out there now. So I had this mix of mechanical and software interest throughout college. And throughout that process, met some great people and ended up, after college, ended up out here in Los Angeles, working for this kind of crazy private rocket launch company. Let's privatize space. Was a really interesting concept then, and a lot of questions around, well, what about NASA and all those things. fast forward, of course, now everybody knows what SpaceX is, but back in 2013 when I landed there, SpaceX was not very well known, and even Tesla, kind of sibling company to us, the first Model S's was, we're just rolling off the line in 2012. So I had this incredible journey and opportunity to end up at the perfect intersection of my background and interests, at a company building in the physical world, using kind of deep physical sciences, but doing it in a very information and digitally forward way as a tech company in many ways. And had that amazing opportunity, kind of amazing way to start one's career, connecting up some of the first workflows and machines at SpaceX to automate production, to collect data in a new type of way to accelerate our ability to iterate on the design of the rocket, on the manufacturing processes of the rocket, and eventually got involved with setting up the data pipelines that allowed us to compare manufacturing data to flight operational data and make calls on the outcomes for flight reusability. So from the very start of getting to SpaceX and just turning on our production engine and solving some of those problems for production automation and machine connectivity to, just a few years later, solving the problems around, landing rockets and working with those folks, but really getting into the operational side of analyzing the data to do what SpaceX has been able to do, launch and land and relaunch rockets multiple times over from a data-driven perspective, is just fantastic. And that experience really baked the DNA for the start of my career, which then ended up leading to a few years down the line, starting First Resonance.
Yeah, so I'm super fascinated with SpaceX, and I remember I read an Elon Musk biography like years ago, where it basically ended with like I think the book ended with like the first successful rocket from SpaceX after they had blown up a few. It was so fascinating to me that no one had really conceived about, like, why don't we just reuse rockets, come up with a way to do that. It always seemed like it was an impossible thing until that point. And I imagine looking through the data and figuring out how to manufacture these things and get that, because you have to have nearly flawless manufacturing to get to that point. I imagine that was a big part of getting to that reusable phase.
Yeah, there's a few interesting things as part of that story. So, you mentioned a few things there, John, that I'll just pull the thread on. That biography and the many stories that are out there, and actually, we're kind of seeing it now unfold in front of us with the Starship program. SpaceX's culture really has been one that indexes on testing early, testing often. And you mentioned, after blowing up a few rockets, it's super interesting. The calculations around what does it mean to test early, test often, and embrace failure, collect all of that data and improve the design. What is very much the ethos of what SpaceX, what led to SpaceX's accelerated success. And, that story has been repeated now a few times with, from the very first Falcon 1 to the Falcon 9 to even, the human-rated crew transport Dragon missions, right? Like going through the test iteration loops to accelerate actually the time. So embracing failure and accelerating our time to actually qualifying, a vehicle that could transport human life. And that has been, successful since then. And, we're seeing it now with Starship, right? Multiple kind of quote unquote failures, but really that failure is part of the program. Very similar to software here. And when we talk about Agile, it's all kind of baked in, right? It's not about perfection. It is about testing early, testing often. It is about continuous testing, and setting up those programs to maximize the end output. So, that was definitely an amazing, vision and kind of modus operandi that Elon had set that allowed us to really take a lot of risks and to continuously iterate, and get those programs right. Few other things that you mentioned on reuse, so it's not that no one had conceived of it. Really, this has been, something that that everyone really that everyone has really wanted. Of course, why not reuse? And when you look at some of the predecessor programs, take the space shuttle for example. Space shuttle was an amazing feat of engineering. A vehicle that could transport large payloads. Things like the Hubble Space Telescope. Take astronauts to space, to the International Space Station, and then come in like an airplane and land. Really, really incredible. The change that we really brought to the industry was doing it in this amazing kind of business model that actually was profitable, as opposed to very, very expensive to do. So what ended up happening, with the space shuttle program and why they ended up retiring it is it was very expensive to actually reuse the space shuttle. Whereas at SpaceX, we had built that into the model. So as opposed to just getting the engineering right, we also got down the operations and that data-driven understanding of what does it really mean to re-enter an orbital class rocket into the atmosphere. What are the loads that are going to be experienced, and what's the cost to actually refurbish the right pieces of the rocket, not the entire thing, but really understand from a data perspective, when do we need to replace the flight computer? When do we need to replace these grid fins or the landing legs or the thousands of components that are on the rocket, rather than tear down the entire thing and build it back up. And part of this amazing journey was every single flight we analyzed that data and requalified what we needed to against the manufacturing operation. That way, we didn't actually have to make the engineering perfect the first time or flawless. We actually, from a data perspective, knew when we needed to replace individual components and when a rocket was actually going to be end of life. And as you kind of look out at what SpaceX is doing today, they'll actually even announce on their webcast, hey, this is the last flight that this rocket will have. And they actually know that, right, from a data perspective, which is really, really incredible. Very similar, again, to the incredible developments that's been done in software, right? When do we know that a certain error is in critical state, right, affecting a broad set of users and not just a tiny fraction, and not, halting all software operations and service delivery on just one bug, right? But rather really having a solid understanding of, what the overall landscape is and making conscious decisions around how we plan the next cycle or the next sprint to address the most critical errors. It's really interesting. Not a perfect analog, obviously. I think you have a little bit more give in most software applications, but some software applications, they're highly critical. Flying rockets is also. So it's a lot of fun.
So tell me about how you took what you learned over at SpaceX and started something new with that. And what is it that you guys do exactly, with that information?
Absolutely.
Right now at First Residence.
Yeah. So at First Resonance, give a little bit of a backstory. I was at SpaceX for a few years. I ended up, I really loved what I did there. Loved the people, I think, first and foremost. But ended up, hitting some blocks on just how bureaucratic aerospace and manufacturing can be. So I kind of had like a little bit of a kind of like side reel, went deep down into data science and machine learning in the MarTech world. Learned a lot there in terms of the technologies available, cloud scale, big data, and modern kind of ML applications. What are the extent of ML, so on and so forth. But did that for a few years and saw a lot of my former colleagues and peers going on and starting the next generation of companies coming out of companies like SpaceX and Tesla. So when I saw that, I got intrigued and interested. Oh, it looks like there's something new and interesting happening here. Had a few hypotheses around how what SpaceX did to really decimate the cost of launch and, kind of getting payloads to space was going to actually change that entire ecosystem. But then also just started seeing, the way that we did these things, people are also bringing out to the market. And what I mean by that is just that operational and data-driven rigor for high criticality types of operations, whether that's in nuclear energy or, again, rocket launch or satellites or, deep sea submersibles, these kind of high criticality environments, I knew that they were going to need to solve the same problems that we had at SpaceX. So that's when we started the company and started looking out for that next paradigm shift, and we're in it now, right? We see just the importance of solving problems in climate change and how energy evolution is going to be a big part of that. We're seeing kind of the increase in human population and how cities are getting more and more congested. Even post-COVID, this is a big problem, globally. So we knew that we were going to have to create the infrastructure and the tooling to be able to solve those problems at scale. So, from that initial discovery to what we are doing today, First Resonance is building a factory operating system that really helps modern manufacturers and modern manufacturing lines to be able to...
When you say factory operating system, what is that exactly?
Yeah. So it's a great question, because in our industry, there are these product categories like ERP, Enterprise Resource Planning. A lot of folks know about those. And then there's product categories like MES, Manufacturing Execution Systems, or QMS, Quality Management Systems. These go back into the 70s, 80s.
Right.
While those systems have, developed and been useful over the past few decades, what has really changed is that we have this huge kind of swell of people who are just dangerous enough with software and things like, modern APIs, webhooks, doing data analysis, and again, the important thing here is not that we have people that are even deeper and deeper, right? We surely have that amazing development with the sophistication of computer science. But we also have people that are like industrial engineers, quality engineers, mechanical engineers that are just dangerous enough, have scripted a little bit of Python, can interact with an API. And that's how we really built the platform. We come from the kind of heritage of what manufacturing systems have looked like, again, like ERP, MES, a little bit of ERP, a little bit of MES, a little bit of QMS. But really, under the hood and the foundation of it is built on an open API that allows modern developers, whether they're computer scientists or not, folks like myself and my background, dangerous enough to make an impact programmatically. Ion has a first-class API that's now being used by these types of folks, right? Again, industrial engineers, quality engineers, mechanical engineers, to automate parts of the factory line. This wasn't possible before. And, the kind of legacy systems just don't allow for it. We all know this in software as well. Some of the traditional stacks of yesteryear, right? The waterfall development methodologies and the large IDEs and the kind of closed systems for developing software has now really unbundled into these very flexible kind of text editors that link up to a CI/CD system that connects with that version control system that can go to the kind of cloud of your choice, right? Yeah. Really composable systems. And that's what we're really, excited for to develop in the manufacturing industry, and really what we're bringing to market with the Ion Factory Operating System to do at scale, while being familiar enough to the manufacturers, right? Because, there's a lot of heritage there. People are used to seeing things like, traditional procedures and quality management types of workflows. So we really bind those two in our factory operating system called Ion to make those things come to life for the problems that we have in this decade.
Awesome. So when you talk about, taking some of these things that we've seen, in software, we've seen people, the trend of digital transformation going from a typical waterfall, gathering these large requirement sets, and then building a project kind of in the dark, hidden away, and then coming out and presenting your project to the end user and being done with this project. That does seem to be the way that manufacturing has been done for a long time, with very detailed specs, very detailed requirements, and then you build a prototype, and once that prototype is ready to go, you mass produce it. Is that what you guys are trying to disrupt, or are you trying to just enhance that?
That's absolutely right. And to your point, John, if you take a software developer from 2023 and you plant them into how software development looked like in the 90s, you would have a lot of heartache, to say the very least, right?
Yeah.
Huge amounts of requirements and specs, and monthly meetings to overview things and hiding developers from the end user and the data coming from the field, so on and so forth. Not only has manufacturing been conducted like that historically, it is very much conducted like that today in many places. And the history of this, I think I will mention, we really don't blame anybody for that. Manufacturing is a very, kind of critical application where if you get something wrong, that could be very dangerous. That could be loss of human life. It could be, an environmental disaster. It could be many things. So the rigidity in terms of the quality control, it made sense, I would say, in the 80s, 90s. But then an amazing thing happened, right? We got the internet. We have now the ability to get data in real time from machines, from people. We have all these devices. So what used to be a very expensive computer shared by 10 technicians out on the factory floor has now changed into a world where every single technician might have multiple devices to themselves. So really what that means is because we have this progress of connectivity and democratization of being able to even interface with digital technologies and software, it means that we really need to turn the page and allow for the same level of kind of agility and democratization that we've seen in software in manufacturing and hardware. While on the surface, it looks like a very hard challenge, the important thing here is that really binding that challenge of being quality critical while making sure that we're not stop gating, kind of the rapid development cycles that are possible now that we have all this data and connectivity and devices in the manufacturing context, is really what we are enabling. So we start with enablement, but also really changing the paradigm with, and I think most of what I'll mention is we're really doing this in partnership with our customers. I mentioned earlier from that experience of being at SpaceX, one of the most incredible things coming out of the SpaceX experience was not the rocket, it was not the technology or the sciences or whatever, it was the people. And those people are really, we look at them as kind of what we've seen in the past, right? Like people coming out of Xerox PARC or people coming out of PayPal and the PayPal mafia. Seeing that now with, these challengers, these individuals who have solved this huge challenge of how do we dock with the International Space Station using this new mechanism that's autonomous, taking on like incredible challenges. And so, but they come with that background of like, yeah, we can move fast. Yes, we can move in a data-driven way. So we're doing this in partnership with our customers. We're proving out that using a modern kind of approach, using the Ion Factory operating system, being in a connected way, using modern web technologies like APIs and webhooks to drive event-driven manufacturing and kind of democratize manufacturing is useful for the manufacturing industry as a whole. So it is really about a combination of innovation as well as just enabling what is already in front of us, right? All this connectivity and all this progress that's been made over the last 20 years. Why should this only exist in the internet and in the commercial kind of commerce sector? Why not bring it into critical types of applications now that these technologies have been hardened and proven out? That's what we're really doing here at First Resonance.
That's super fascinating. And when you talk about, you mentioned a little bit earlier about big data and having all this information. And I imagine with manufacturing, from every run that you do, you have a lot of data, and that data needs to be processed in some way. Is that something that you guys help with?
Absolutely. So, it's you're right. I saw a statistic a little while ago, and I forgot the exact numbers, but one of the most data producing industries in the world is manufacturing. The problem is where and how that data gets stored is all over the place. It's in file systems and stores and on local computers, so on and so forth. So for us, working with our customers, one of the most exciting kind of like low-hanging fruit pieces of this is just let's get a way to get the data into a way that everyone in an operation can access it and start making data-driven decisions. And the interesting thing here is we don't even have to do all of that in terms of the decision-making. Really what the Ion platform enables is just having that accessibility, right? Changing that paradigm from massive amounts of data being produced and tucked away on a local hard drive or just a shared network drive into kind of these modern concepts of a kind of like data graph of where your information is produced and where it's available. So we do very much help with that. And we've seen some really fantastic applications of this, right? You can imagine, I'll give you an example. We work with a company that has a lot of electrical engineers defining what the product needs to look like. And then, they have their counterparts on the manufacturing side that actually build these electrical boards and these like full electrical assemblies. Now, historically, that would be great. Let's do the engineering, let's define it. And then let's do the manufacturing, and that'll be its own world. What we have done with this company, it's really incredible. Actually created an interface where they could get real-time current and voltage values going through every single one of their boards in the manufacturing process and start correlating that data so they could better understand how a change in even something like their supplier for the solder that goes onto the board relates to their engineering designs and tolerances in near real time. And so they're actually able to work with their manufacturing counterparts in a much more agile fashion. What used to be something that they only used to do in like these big blocks, even on a quarterly or like a biannual basis, has now turned into a weekly review meeting where they look at just design changes, the supply chain changes on a weekly basis, and are able to influence the manufacturing process and also influence back the design at the CAD level to make a better outcome from a quality perspective and a performance perspective, again, on like a cadence that was previously just like unimaginable, right? Weekly changes to the design and process to make this incredible product that happens to be cutting edge in the application that this company works in.
Yeah, so it sounds like one of the things that really hit home a few years ago during COVID, during the whole lockdowns and things that were going on, was supply chain issues and not getting products in place, and that shut down a lot of manufacturing. And it sounds like now we can kind of have a quicker response time to, we're going to have a shortage coming up over here. What will switching to this supplier do to the bottom line? You guys can figure that out a whole lot faster now than you could before. Is that what we're seeing?
Absolutely. And John, to give you an example of, an inspiration for us, there's a case study that we talk about here at First Resonance when we talk to new prospective customers. Mm-hmm. In 2020, I think some folks that are listening in may have followed the chip shortage issue and how that was affecting the automotive supply chain. So when we looked at this, we saw some of these examples, and I won't name company names, but let's call them legacy auto manufacturers. When they were hit by, some of these changes and disruptions to their supply chain, we saw an example where just one microchip. So we're not even talking about like the EPU, the engine processing unit. Like we're not talking about the big systems computers or like large infotainment. I'm talking about just like a microchip that does something as simple as, manage the windows, right? Lowering and raising the windows. How a change in their supply chain and a disruption to the microchip production actually led to a complete halt of those vehicle lines. Because they had done their design, they had locked down all these bill of materials bombs, and that's how they were running their manufacturing line. So as soon as you got something that ended up disrupting that supply chain, they didn't know how to adjust for this at all because, like I was mentioning earlier, all the engineering is done up front and then it goes into manufacturing operations. They just stopped the line. Whereas we saw, modern vehicle manufacturers, and to name one, this case study is out there, Tesla, when they were disrupted by some of the microchip availability, and keep in mind, this is a very digital car, right? It is very driven by software, et cetera. So you would think that this microchip change would have actually affected them and, kind of blown them out much, much more harshly than some of these other automotive manufacturers. Tesla not only responded to that supply chain shift, kind of at the higher level software side with rapid software changes to account for that and reroute some of the redundancies in the vehicle, so on and so forth. But also at this microchip level, there's a very specific example where the microchip that runs the charging pad on a Tesla, for listeners that have been in a Tesla, that at the front console, you know, they have the wireless charging for your phone.
Yeah.
That microchip, what they decided, and this is also where, you know, software meets supply chain meets business decision making. They realized, hey, nobody's buying this car to charge their phone. So what we're going to do is actually just take that chip out of that application, because that supply chain has been disrupted, and we're just gonna keep shipping vehicles, because they're really buying the car, you know, to do what the car does, to drive themselves around, and they can charge their phones when they get home. And because they had this level of kind of traceability, they actually shipped these vehicles. People got what they were actually, you know, what the demand actually was. Hey, I want a Tesla so I could drive it and get from A to B. And then because they had the traceability for what vehicles had been shipped without the working charging pads, they actually sent an in-app notification, right? Tesla has an app to call that vehicle back to the service center once that assembly was ready to be retrofitted. And this is all, if you think about it, just the seamlessness of that agile process, right? Understanding where you are in the supply chain, being okay shipping something that is incomplete but not dangerous, and then coming back to it to really drive the customer value from a time, cost, and availability perspective. To me, this is an incredible case study of what these modern principles brought to life in manufacturing could look like. And we're going to see a lot more of that in the world as kind of the demand for various types of hardware technologies and energy and modern kind of cyber physical systems like a Tesla car really, you know, kind of increase in application.
Yeah. And, you know, I have 2 Teslas actually.
Oh, nice. Awesome.
And one of the things that I was told by one of the guys at Tesla, because my wife's car, she got it before mine, and hers has, you know, the built-in home link thing where you pull up, the garage door automatically opens up and it does its thing. And mine didn't. It was an aftermarket, and I had to buy it and like get it shipped to me and put in. And I was like, well, why is that? Why did they stop doing this? And he told me it was a supply chain issue, that we just made the decision that we're not going to keep those in the 3s and Ys going forward. We're going to take those out. We're going to keep them in the X and the S because they're higher end. And if you want it, you can pay $300 and we'll come out and install it for you. And that way we can continue vehicles moving.
Oh yeah, awesome. That's such an incredible story. I'll tack one on there, John. I mean, that's awesome, right? Like while driving around, you probably have this experience that you're really, you know, you're driving in software, or at least something that's so enabled by software. There was another case study that I'll mention with respect to Tesla. They, you know, because they get all this data on how the car is used, they're actually making design decisions based on how the consumer really wants to use the car, just like we do in modern software development with all these, you know, kind of analytics tools, things like Mixpanel or Amplitude and Google Analytics to make better decisions for how we should craft the software. A few years ago, you know, so the original Model 3 used to actually ship with lumbar support adjustment on both the driver's side and the passenger side. What they saw through the data was that on the passenger side, only some like small percentage of the users, right, of riders in the car actually adjusted their lumbar support. And so for cost perspective, like for cost savings, not just for the company, but to pass that on to the consumer, they actually took it out of more recent Model 3s. And Elon was on Twitter just kind of laying out the data that they saw. Hey, we just saw that this wasn't in use, and so we took it out. And that's amazing, you know, when we think about software, when we see, you know, parts of the application that are unused or really not driving value to the customer, let's take out that technical debt, right, and build and ship a better product.
Yeah, I love that. Now, some things have been taken out that have annoyed me, but I guess they're also probably because not enough people have used them. Like, for example, in my Model Y, when I first got it, I had Sonic and I had other games that I could play. And there's a bit.
Oh, totally.
But
Totally.
there's still my wife's car.
Sonic as well. I actually miss Sonic as well. I'm with you.
But I imagine, yeah, there's a lot of data and analytics to go into that and saying, is it worth to pay the license, you know, per se, to have this game or not?
So interesting. Yeah, I bet you're right.
So real quick before we, wrap up, I was curious if you could tell us a little bit about how, how has the manufacturing industries as a whole kind of responded to some of these changes that you guys have kind of created and seeing kind of this digital transformation that's going on with manufacturing?
Yeah, really good question. So, one thing I'll mention is that manufacturing is one of the largest industries in the world. We're talking about multiple trillions of dollars across a vast array of, things. It's just almost everything, right? From everything from apparel to beverages to food to cars, planes, trains, computers, etc. We focus on, a bracket of that because we know what we do well. The industries that I mentioned earlier, aerospace, automotive, robotics, energy, these are quality critical applications that make a good fit for what Ion brings to market with the level of traceability and quality workflows that come embedded in the manufacturing process. So we focus on that. Now, even within that, I'd say, honestly, it's a mixed bag and it's very early there's no clear signal, meaning because the industry is so large, we have those that are a little bit stuck in their ways, right? They've had what has worked for them for many, many years, decades, and so they're unwilling to change. And then we have, the modern manufacturers that are taking risks and bets and even baking into their business practices and their business model that in order to do what we want to do well and at cost and to deliver the value to the customer, not only do we need to be innovative on the type of product that we build, but we need to be innovative on the operations that we use to actually drive building that product. So ever since COVID, I will mention, it has been really great to see people's minds really shift in response to just how much of a challenge we've all gotten ourselves into with the kind of rigidity of the practices from before and the supply chain disruptions, et cetera. Everybody's opening up their eyes to, hey, we need to respond because we can't just depend on this kind of old world order of very predictable and rigid workflows to get us where we need to get to. So what we found very beneficial is that, there are these people out there that are now really taking risks in terms of the systems that are used to build their product and succeeding because of that. I'll give you an example. We just posted an example on LinkedIn. We're working with a nuclear microreactor company. Now, that's a pretty big and complex application, quality critical, of course, as we'd all hope. They're actually using Ion to power their supply chain and their assembly processes. And they actually shared just how much of a impact using Ion has on their processes to be able to iterate quickly while also having the traceability that's required for such a quality critical application. So I think, these things don't happen overnight. To your point earlier, John, everybody has their eyes on digital transformation and Industry 4.0. It's really a matter of relationship building and trust building and, credibility building, showing, kind of the old guard what is possible in even the most high criticality types of applications and working in partnership to show them how it could work for their operation. But the reason that we have these terms like digital transformation and Industry 4.0 is a little bit, they're so broad. There's a little bit of this like, well, we don't exactly know what we want. We just know it's a little bit different than what we had before. I think it takes a little bit of a leap of faith and also studying, the credibility and the success that this new approach has had for the most innovative companies in the world that are using Ion. So, we're on this journey for the long haul. It's not going to happen overnight, but we're thrilled by the opportunity to start changing hearts and minds.
Well, that's awesome. So if you don't mind, just tell the audience a little bit about how they can maybe learn more about Ion, our operating system and what you guys are doing over at First Resonance, and maybe connect with you online.
Absolutely. So anybody that is interested in checking out really what we are bringing to market, you could go to firstresonance.io. That's resonance, like a resonant frequency. And we also have videos on the website that walk through the UI of the platform, as well as our API docs that show developers examples of how to interact with complex systems like a factory using the Ion API. So you could check out the website and learn more. For anybody interested in coming to work with us, we have a careers page that you could learn more at. If you want to get in touch with me and follow us along in our journey, I'm on Twitter at Karan Talati. That's KaranTalati. Also on LinkedIn. You could search for Karan Talati and follow me there.
Awesome. And I'll link all that up too in the show notes at geekleader.com. It's been a great conversation. I really appreciate having you on the show.
Fantastic, John. Thanks so much for having me. Incredible to talk to you about, how the world is changing, and, very excited to see how your listeners, change the world in new ways in the decade ahead.
Yeah, absolutely.
If you enjoyed that episode, please leave a rating and review in Apple Podcasts. I'd greatly appreciate that. And also, don't forget to check out merch. We have some T-shirts that I've designed that are on at geekleader.com. You can click on the merchandise section there and check that out. And also, don't forget about the books from our guests. So if you like this guest and other guests that have written books, please go ahead and check that out at geekleader.com. I would greatly appreciate it, and I'm sure they would too.